Thank you. Thank you very much. Anthony Seppi, I'm Program Director for Pipeline, H2O, and what you guys are about to witness, these guys are changing the world. This is our second class of Pipeline. 2017 was our first class. This is our second class. These guys are doing amazing things. You'll get to see that in a second. But, you know, why are we doing this? Why Pipeline H2O? Why Cincinnati? Why Hamilton, Ohio? You know, we love water. We're all about water. We're passionate about startup businesses. You know, that's kind of the why. That's why we're doing it. These guys are doing amazing things, you know, in terms of the program and some of the challenges that they're addressing. Challenges such as, you know, water reuse, water scarcity, water quality, water infrastructure, consumer innovations around water, and you'll see some of that. So that's really the why. You know, it's just a passion around water and a passion for startup businesses and assisting startup businesses. And so that's what we're doing. That's what we've been doing since February. We're in our third month of the program, and these guys we've been practicing our pitches, and they're going to come up here and do that in a sec. So how are we doing it? You know, it's collaborative. It's partnering with the right organizations throughout the region. University of Cincinnati, Confluence, a lot of the local utilities, a lot of the local business and industry. They've got challenges around water. So partnering with the right organizations, as I mentioned, universities, Miami University, Northern Kentucky University, University of Cincinnati. So that's really the how, and it takes me to the what. You know, what are these guys doing? And they're going to talk about that. What are they doing? What are the challenges that they're addressing? Not only here in Cincinnati, but you know, throughout North America, throughout the world. So we'll, without further ado, we'll go ahead and jump into it here. We got Scott Edwards with Drop Water.
Thank you. Oh, I heard the mic. Test 1 2. All good. Hey guys, can you hear me? Good? Good. Okay, so my name is Scott Edwards. I'm the founder and CEO of Drop Water, and we're reinventing how bottled water is manufactured and distributed. And I think we found the key, finally, of how to make sustainable bottled water for all generations to come. And we're doing that by using robots and sustainable materials. So I think that we all know plastic waste is a global problem, so I'm not going to talk about it or go into it too much, but I'll tell you a story. So I was walking on a beach in Kauai, and I saw a bottle of water on the beach, and I took a picture of it because I thought it represented really what's going on. So if you think the bottle is the problem, it's not the problem yet. What the problem is, actually, are all these things. So that's microplastic. What happens is the plastic photodegrades, turns into small pieces, it's being consumed by nature, and it's going to affect our lives in the future and future generations. So to really put into perspective how much plastic we're actually using, in 2015, the United States alone produced 50 billion bottles of water. That's enough to go from the Earth to the moon over 26 times. And if you consider that we all have to share this Earth for all generations to come, it's probably about time that we switch over from pieces of plastic that last forever and muck up our environment to materials that are actually processed by nature. So this is what we've been working on for the last 4 years. This is a 100% compostable bottle. And the cool thing about this bottle is that it doesn't have to survive that long journey from where it's made to where it's consumed. It doesn't have to be indestructible like these bottles. It can now be 100% compostable. So you get it from these machines, and this may look like a standard vending machine, but it's not. It's a mini bottling plant. It holds over 1,200 bottles that are empty. It's hooked up to tap water, and we filter that water to perfection and fill drinks at the point of purchase. So a consumer can go up to the machine, choose what they want in their drink. They can choose from a variety of natural flavors. They can choose how many milligrams of caffeine they want, from a cup of tea to a strong cup of coffee. They can even choose temperature. So this is a video of Brittany over here using the machine. So you just use our intuitive touchscreen display to choose what you want in your drink. She chose no caffeine, cold, and you can pay with a standard credit card, our mobile application, or even Bitcoin. It's processing the payment. Payment went through, and now the machine's going to show the nutritional facts of the drink she ordered. So 0 calories, you only use natural flavors. If you got mint, cold, no caffeine. And in less than 10 seconds after the transaction, we've created a drink at the point of purchase in a 100% compostable bottle. So the industry we're initially going into is the vending industry. It's a $20 billion market in the United States, and they have over 100 million daily visitors. So it's really us versus this old method, and I'm going to tell you why we're a lot better. So traditionally, has anyone ever stocked or restocked a vending machine? So you'd know you'd have to bring a truck, you'd have to bring a few hundred pounds of bottles on a dolly, restock it one by one. It takes a long time. It's inefficient. What we do is we ship all of our bottles in stacks like this. So that's called a bottle tower. That's 1,200 bottles, and that's 1,200 normal bottles. And yeah, they stack together like this. This is a patent-pending method. So this means we transport less weight, about 1/20th the weight, and we take up less space, about 1/10 the space. So just a fun fact, we can actually transport more drop bottles in a Tesla Model X than traditional companies can transport in a 22-foot box truck. So a lot more efficient. Another great benefit that we have compared to everybody else is that we have custom branding that's being targeted to very specific consumers. So we know exactly where each bottle is going to. We're shipping bottles directly to these points of sale. So maybe it's in an airport. We can put on custom branding specifically designed for that demographic. So let's go through the bottled water value chain. So currently, we take oil out of the ground. We make resin out of it. We produce bottles. The bottles are filled. The bottles are then put into cases. The cases are put into pallets. The pallets are put into trucks. And all that water has to travel over the earth and get to where it's sold. We're shortening this process by a lot. So we manufacture our bottles. We put them into those bottle towers that I spoke of. And we ship it using traditional methods straight to the point of sale. And I'm going to toot my own horn here, but we won the 2018 FedEx Small Business Grant a couple days ago. We're looking forward to working with FedEx. Thank you. So let's talk money. We're going to be profitable with only 6 machines. And we're going to do that this year. So we're going to put these machines in a major international airport. We already have an agreement. We're going to get about a 47% gross margin when all is said and done. And at 100 kiosks, we're going to have about a 57% gross margin. At over 1,000 kiosks, we'll have about a 67% gross margin. We're initially entering the Bay Area, so we're launching 100 machines in the next 12 months. We're partnering with Survey Studio to help us place machines in the right spot. They've helped other kiosk manufacturers and companies like Redbox, Coinstar, EcoATM. Just as for perspective, there are over 50,000 Redboxes in the United States, and we're looking to put in over 100,000 of our machines just in the United States in the next 10 years. So there'll be a few different product lines. Right now we have a very large machine with a large capacity. It's actually smaller than a vending machine, but 5 times as many bottles. So let's look at our milestones. So we made a minimum viable product a couple years ago. We tested that product in initial markets. We worked with companies like Twitter, Anaplan, Plug and Play, Ducky's Car Wash, and a concert venue. We discovered this is actually going to work. People love this. And then we designed a machine for manufacturability. We're done with that. And now we are testing shipping directly to points of sale from our manufacturer, and we're about to be in a major international airport with over 33,000 daily visitors. So we have a team that's assembled that's passionate about making change. We have all the required skills. So I used to work at Red Bull. I have a background in robotics, packaging, and beverages. And we have selected carefully, and it's evolved over a long time, the perfect team to bring this product to market. So thank you for listening. I hope you can join the mission for Drop Water. If you have any questions, please let me know. Yes, sir.
So I think it would make a good pitch on Shark Tank.
You think it would make a good pitch on Shark Tank?
Yeah.
That's awesome.
Assuming you're in Shark Tank, the typical questions would be, the last thing they say is, what are you looking for, what share in the company, and then they talk about it. So I'm trying to, in that sense, that plays into your vision for the company. So how would you answer a question from Shark Tank related to that?
I would say that we're looking for enough capital to get to massive production and to get our cost of goods sold down to a good price to have a good margin on it. I think we're well on our way already. So I think I'd say we're more looking for key partners that are experienced in this area rather than money itself. Any other questions?
Scott, I'm the other airport guy,
Hey,
and our airport's not up there. Are you under exclusive agreement with San Jose?
we're not.
That's good.
We want to be in many airports. We wouldn't.
So
Yeah.
when's their launch?
I can't say, but it's soon. It's this year.
Right.
Oh,
We're right down the street, Scott.
well, I'm from California.
We're right down the street, Scott.
Okay. Let's do it.
I just had a really fast question. You might have mentioned it, but how much do your bottles of water cost?
They'll cost. So we're competitive with traditional companies right now. So it'd be a normal price. We can't compete with bulk water. That's like less than 30 cents a bottle. So it depends where it is. If it's at a college campus, you'd expect about $2.50. If it's at an airport, you expect more than that. So right at market price. That's it. Thank you.
Thank you.
Let's hear it for drop water. All right, so next up, we've got Karen Sorber with Micronic Technologies out of Wise, Virginia.
Does this one work?
You can also take it off if you want to walk around.
Yeah. Good afternoon. My name is Karen Sorber, and I am the CEO of Micronic Technologies. And we are totally committed to helping to preserve the world's water resources. This isn't working. I met this little girl in Peru. She had no access to clean water. I had been in the United States my whole life and had no problem, just turn on the tap. She didn't have that option. I learned a lot about third world countries, developing countries, and the problems they're having with water. And I knew one day I would do something about it. And this is just giving me a fit. What do you do, Scott?
That's not me.
So where can we get water to help take care of the thirst of the world? It's like Willie Horton said, why are you robbing banks, right? That's where the money is. We got to go to the oceans. That's where the water is. When you desalinate water, it's pretty complicated, it's very expensive, and a typical system looks like this, reverse osmosis. It uses a series of membranes and pressures and temperatures to clean water. And that's good. And there's a big push to do that around the world. What's the problem with desalination? When you're desalinating water, if it's seawater, you're going to create a certain amount of brine or waste. About 60% of it will come out in brine or waste, and 40% will come out in water, clean water. And if you're in the inland or the brackish water, which is inland United States, you might get 20% brine. But the bottom line is it creates a lot of brine, and that is not good. The problem with brine is disposing of it. If it's not properly disposed of, hazardous waste can get into our streams. Fish kills can happen. We can have problems with the ecosystems. And of course, you can't reuse the water, which is what everyone's trying to do now because we've got such a shortage, a scarcity of water. So what's the industry doing about it? They're now starting to look towards zero liquid discharge. where instead of having that 60% brine, they'd end up with nothing in a discharge, liquid discharge. And they do that in a variety of technologies where they get 95 to 100% out in clean water, 0 to 5% solids. It's very expensive, but it enables 100% reuse or disposal of what might be remaining. Our technology, micro evap, is a solution for ZLD, zero liquid discharge. We can reduce the waste by 95%. We can treat very, very high concentrations of salts. We're more cost competitive based on our modeling. We have 6 issued patents. We've launched our field pilot. We're smaller footprint environmentally and physically, and we're modular for scalability. We have industry validation, and here I'm going to show you a little video. This technology is very unique. You have a tornado that's actually being created in this cylinder. Water and air is coming together and hitting a patented pod. What? Oh. That's okay. So it's using a patented pod, and I'll hand this around, and Brianna, you keep an eye on it. Make sure nobody steals it. It's a patented pod that creates a tornado. That tornado instantly evaporates the water. Evaporation takes all the chemicals out. It takes all of the salts out. And then the remainder gets condensed into clean water. So how is it doing it? It's doing through this turbulent flow. What's different about a turbulent flow, it's going to be very easy to process the dirt, and you don't have scaling. You don't have scaling because the water droplets are moving through the air, and the brine is coming out into a brine tank very quickly after it's evaporated. These are our results. If you look at the first one, 26,643 parts per million, that was input into our system. 500 parts per million of those salts is what EPA says is suitable for drinking water. We got it down to 103, and so on, as you can see. That's what we're doing. We're getting it out of the water, 99%. What else are we getting out besides salts? Up in the top left-hand corner, we also have bacteria, nitrates we get out, nanoparticles, pharmaceuticals, and suspended solids. We have 2 PhDs from Virginia Tech who have done papers on nanotechnology and pharmaceuticals because there's nothing else that can do it. What else is great about our system? 95% of that brine comes back into reusable water. So you're able to take what was a lot of waste and get it down to a mere 5%. So what's our market? The desalination market is very large, 27 billion, getting to 27 billion a year in 2025. The ZLD market is going to $9 billion a year. And the brine concentrators are part of that market, which is where we're going. And physically, geographically, you've heard about the Southwest of the United States having a lot of problems. Well, they're not even allowed to surface discharge any longer. Often they can't deep well inject. They can't do sewer discharge. And so they're really looking for a solution. So our market will end up being a combination of municipal, power, mining, and industrial, where they're doing brine concentration from a desalination or a reverse osmosis system. We're going to go through design firms and product firms to get to market. And we have 2 clients, we have 2 partners right now in those areas. What's our advantage? It eliminates these things on the left. No, there's no scaling, there's no chemicals or membranes to be used. It reduces water fees, sewer fees, mini fees. We think we're 35% cheaper than in a small unit, and a larger unit about 60% cheaper. We have a Delaware C Corporation, external board of directors, partnerships with the academia over there on the right, and we have Baker Hughes GE as a contract with us. We have EPA. We're negotiating a R&D program with them, and Black & Veatch is working with us on that CRADA as well. These are our milestones over the next 18 months or so. Bottom line is we need to make sure it does the efficacy, that it takes the stuff out of the water for clients, do the return on investment with clients, and pilot the technology. Over the next 3 or 4 years, we'll be having this trajectory with sales at the top. We'll start with a 1,500 gallon a day unit and then go to 125,000 over the next few years. So this is me and another little boy and his mother in their hut in Peru. And when I get this to market, I want to be able to go back and help these folks get clean water. And I'd like for you to help me too. Questions?
How do they afford to start this system?
Yeah, so our market, is going to be here in the United States, desalination, the brine, back end of desalination. That's how we will get to market. My desire is to be able to help those people in the long run. That's what started this. I met a man and married the inventor, and he and I want to be able to give back to Peru and other places once we've been able to go to market.
It's a real challenge.
It is, and I'm not the only one working on it. You know, people across the globe are working on that problem. And this is just one more opportunity to help.
It sounds like your technology is versatile enough to handle more than just brine or salt. Are you also looking at like industrial wastewaters and other contaminated waste streams that might need to be purified?
I would love to have.
Karen, can we get a repeat of that question? And
Oh yes.
yeah,
The gentleman was asking whether or not it appears that our technology is more versatile than just taking out the salts or total dissolved salts out of water, because it is an evaporative process, and you're spot on, and it can, and it does, and it has. We've gotten everything from nanoparticles, leachate, we've done cooling water blowdown, we've done gold mines and acid mine drainage. What else have we done, Brianna? I mean, a million types of water we've been able to clean. Our technology to get to market at small scale will be more practical if we go in the brine discharge, because those markets you're describing are very, very large scale. But we will get there. Thanks for the question. I'd love to talk to you after. What other question? You got another one?
Places where they have excellent groundwater and they can produce water, places where they have excellent groundwater and they can produce water cheaply and very good. That's not one of your sources, one of your locations.
No, but I'd like to live there. Where's that? It's really desalination, the back end of desalination, cleaning up that water. Probably the southwest of the United States will be where we go. More questions?
What's your solution in the Southwest?
This unit, we're going to design this unit that you saw, the tornado that you saw in there. Okay, we've got an industrialized pilot now that's in our facility right now in Wise, Virginia. It's about 5 by 5 by 5. We're going to do a pre-production unit now over the next 18 months, get it proven out in a couple of plants, and then we'll sell that unit to people who can afford to buy it, and we will potentially service as well. So we've got people in Arizona, for example, that would like to use it in the oil fields out there, and so that may happen. So we just sell them a unit. It's really easy to operate. I can actually turn it on. I'm not the engineer. Yeah, it's not going to be cheap, but it'll be a lot cheaper than what's out there now. There's got to be another question. Okay.
thank you, Karen.
All right, thank you, Karen. So next up, we've got Robert Lee with Geo Interactive, and he's from Sydney, Australia. So we've got folks coming from around the world for the program. So I'll turn it over to Robert.
Okay. Hello, everyone. My name's Robert Lee. I'm the CEO and founder of Geo Interactive, and we're modern-day pioneers exploring dangerous places, or more like real-life Indiana Joneses. We want to be amongst the greats like Charles Darwin, Sir Edmund Hillary, and Neil Armstrong, and create discovery robots like Mars Curiosity rover. And our ambitions are to explore deep underground on Mars in search of evidence of life. But before we can go up shooting on SpaceX rockets, we've got to deal with real problems down here on Earth first. Over the last 2 years, I've been doing customer discoveries in several underground environments. And one of the environments that I literally fell into is dark. It's dangerous, which makes it exciting, but it's totally disgusting, is the sewer. And over those 2 years, I've been going down underground, understanding what the utilities have to look for and what the problems are down there. So what I'd like to do is give you a bit of taste what I've gone through to give you an understanding. And here it goes. It's usually 2 o'clock in the morning when you're all fast asleep, not flushing your toilet. You lather your skin with a thick cream, blocking all your pores from the pathogens. You clip your harness on, you get lowered down, and you land in about a foot of sludge. Your glasses fog up, and then you bind for a minute or two. You unclip your harness, you let go, and you're all on alone. You've got the next several hours to walk miles in waist-deep sewerage, trying to not slip over. And as you're walking along, there's noxious gases air just waiting to take your breath away. And acid drips from the roof, quite literally. And why are these people, like me, going down there to inspect these pretty horrible places is because the sewers are aging and degrading, and they're failing, which is causing over 850 billion gallons of raw sewage overflowing into our waterways. Waterways that you and I swim in, drink from, or get our food from, making millions of Americans sick. So how they try and prevent these failures is that they have to inspect them. And with the current approaches today, they're very inefficient, very costly, and very subjective. So at Geo Interactive, we've utilised the advances in robotics, computer vision, and machine learning to come up with hardware and software solutions to better inspect and manage these assets. And what we've come up with, this is our hardware solution. It's called the Sewer Scout. It's untethered, it floats, and it inspects the pipe as it goes through, not needing me going through there. This is a pilot study done back in Australia with Sydney Water. As you can see, it floats through and it will start capturing raw data, quite similar to Google Street View. That data is then uploaded to our servers where we process it. We geolocate every image and then we can geotag all the features in that pipe. This allows us to monitor change over time, or rates of change I should say, so utilities understand when they need to fix the pipe. This is our software solution. Much like Google Street View, it allows the clients to virtually tour their sewers as many times as I'd like. At the moment, we're using the humans to classify the features that they see, but what they classify is going into our machine learning bucket, and we're going to allow the computer to do the feature detection itself. So we're about 5 times more cost efficient than traditional approaches. We can inspect up to 60 times more sewers than CCTV. And we're looking to dominate a $3 billion a year sewer inspection market just in the US alone. Our business model is quite like a mobile phone. It's a hardware as a service. We plan to lease out these units for a single use or an annual subscription. We'll then charge the clients a $2 per foot processing fee to geotag all these images. And we're giving the viewer access for free. We've already generated over $108,000 US in the last year just using our prototype systems through pilot studies. In 2019, we plan to do $1.7 million just with 10 units and mapping 125 miles of sewers. In 2020, we plan to do $8.8 million recurring revenue with 50 units and mapping over 600 miles. And how we'll do that? Well, this is my team. And it consists of me, CEO and founder of Geo Interactive. I have over 10 years industry experience in and around underground environments. I've worked as a geologist, geophysicist, and photogrammetrist, and come up with several imaging systems for the underground environments. We've got Matt Clark in the middle, who's hiked through Nepal by himself, but worked for the UN managing technical teams. We've got Angus Mitchell, who also lived up in northern India by himself for months on end, and he's our machine learning guru. Ashwin Varshney got chased through China by rabid dogs, and he's our embedded engineer. And you can kind of get a sense of who I'm looking for. These people are confident. They are all about discovery and adventure. We have Daniel McMillan, our full-stack developer, chases cows on his dairy farm on motorbikes. And we've got Shalong Liu, our computer vision expert, who's uprooted his family to come to Australia in a foreign land. So Geo Interactive is a company built on curiosity, imagination, and adventure. We plan to map out and discover all the dangerous places here on Earth and beyond. We are the Google Street View for dangerous places, starting with sewers first. Come on a journey with us. I dare you to. Thank you.
Question.
Are all your little units that same size, rather small, and do they collect samples in those little containers?
We don't collect samples at the moment. We just look at the condition of the pipe above the water, and we're developing a new sensor that maps underneath the water as well. But we have been asked about testing for opioids in the water as it floats along, but that's something further down the track, I think.
Do you foresee any capability or possibility of integration with smart sewer sensor systems?
Oh, definitely. We're already thinking about it in the IoT space. A lot of the manholes are turning into smart manholes, and we want to utilise that technology to better locate where we are underground. We do our geolocation post-process. We would like to start doing that in real time and maybe using or syncing up with those sort of networks.
So what are your barriers to widespread adoption? Is it regulation, or is it just a basic misunderstanding of what the system does for water management systems, or why are they not adopting your system, or are they?
Well, I should say there's a market pool at the moment. So every utility that we talk to wants a system. We aren't currently at commercial standard, so we've only got prototypes. So we're testing that out and iterating the design. Some of the barriers to market, I guess, a lot of the utilities already have existing solutions that they've either spent a lot of capital on or they just don't know what to do. So we've got to try and align ourselves with the next budget to get in, to push out those outdated technologies. That was a tongue twister. So that's some barriers. We're looking at the developed world at the moment, English-speaking countries that are very similar to Australia, US, and the UK, that all have similar frameworks. But understanding the landscape in America is proving a little bit more complex than we originally thought. Great.
Cool.
Thank you.
All right, thanks, Robert. So next up, we've got Steve Chamberlain with Water Warriors, and they're based here in Cincinnati, Ohio. So.
All right, good afternoon. On behalf of Water Warriors, we'd like to thank you for the opportunity to share a little bit about ourselves. I'm Steve Chamberlain. I'm the Director of Business Development for Water Warriors. And today I wanted to highlight a major problem that is a global problem. And that is that every day our waterways are being contaminated by pollutants. And although there's several contaminants that are out there, there's two that I want to focus on today, and that's nitrogen and phosphorus. Now, before I became a water warrior, I didn't know that nitrogen and phosphorus were even pollutants. But it's true. They are harmful for the environment, and one of the major reasons is they are the cause of toxic algae blooms. Now, toxic algae blooms are harmful to wildlife, but first and foremost, they jeopardize our drinking water. And you may remember a toxic algae bloom outbreak in Toledo, Ohio, back in 2014, which did contaminate the drinking water. The EPA calls it one of the most costly and widespread environmental problems. So what do we do about it? I mean, we got to remove the nitrogen and phosphorus before it gets into the waterways, right? However, that task has become increasingly difficult for our wastewater operators. Many plants are not equipped to remove that nitrogen and phosphorus. I mean, the good news is that we've identified the problem. We know we need to get this out of the water. And so stricter discharge limits are coming with that because we know that's what needs to happen. But unfortunately, the plants are not equipped to meet those stricter limits. And I talk to a lot of people each and every day. And if the stricter limits have not been imposed, they're coming. And that's where we come in. Water Warriors provides innovative wastewater solutions to treat water and remove, in particular, nitrogen and phosphorus. So how do we do it? It's a new approach, an innovative approach to treating the wastewater. And I'm going to restrain myself from making a bunch of warrior references or battlefield references, but I'm going to let myself go a little loose and just say, if we are warriors, these are our weapons of choice. Okay? You have the media, which is open-celled foam. And for the purpose of this presentation, I want you to think of the media as a place for the bacteria to house themselves. Okay? Bacteria is like tens of thousands of volunteer employees in the water working 24/7 to cleanse the water. And then microbubble aeration is the other weapon of choice. And bacteria need oxygen to survive and thrive. And this is our method to get that oxygen to the bacteria that they need. Now, depending on the project, you might use one of these products. You might use a combination of the products. You might use all three of the products. It all depends on the project and the need. I'm going to dive into each briefly, just to kind of give you a quick overview. You have super biomedia, looks like a football. The interior, again, is the foam, which is the home for the bacteria. It tumbles in the water and cleanses the water by increasing that biological activity that you need to remove, in particular, nitrogen and phosphorus. Okay, waving biomedia. Now, this is more for a lagoon application. You see these lagoons in our picture. Can be massive. And many times, the water is sitting there and not being treated to the level that it needs to be. The waving biomedia gives it the opportunity to treat the lagoon. Now, I'll give you an example. In a application in a chemical plant, typically they were seeing about 2,500 to 3,000 milligrams a liter in biomass concentration. With our product, they saw 42,000 milligrams a liter, so a substantial increase, and which made it more effective. And here's our microbubble aeration. The bubbles will be the perfect size, 50 microns or less. That means that they'll stay in the water for up to 4 hours, which gives you that opportunity to have the oxygen transfer that you need. The benefits of our products. Again, it gives you that increased biological activity to remove the nitrogen and phosphorus, reduces sludge, which is a cost saver for many plants, increase the facility capacity. Okay, they're very simple to install. There's no infrastructure build out. And many times we find that we can save up to 50% in energy savings due to the efficiency of the microbubble aeration. Part of our process, we have a computer simulation model, which will allow us, once we collect basic information that plants typically track on a daily basis, that we can input that into our computer simulation model and then allow us to design for that particular facility, letting you know how much biomedia is needed as well as if there's any aeration needs. So who are water warriors? This is our team. John Gradick, CEO. Dr. Rakesh Govind, who is our Chief Science Officer. Rob Foster, who's a mechanical engineer extraordinaire. And this is me on the end. I just sit around and throw papers in the air. And for this presentation, I left my other 6 arms at home. So how are we doing as far as revenue is concerned? Our forecast for this year, $1.25 million. I'm happy to report that we're 40% to goal for 2018. 2019, $2.3 million. 2020, $3.1 million. Now, I want to tell a quick story in a recent meeting that we had. At the time, they were a potential client. And 15 minutes into the meeting, they stopped us. And the head plant guy, the guy in the plant leadership position, he said, "It's become obvious to me that we have been dealing with civil engineers. You are wastewater experts." And why did he say this? And the reason is the problem that they've been trying to solve, they've had nothing but the problem solution was always build more. You need a bigger plant. You need to spend $20 million was the price tag. We came in, and not only will we solve the problem, but our price tag, $3 million. I encourage you to visit www.waterwarriorsbiomedia.com for additional information. And at this point, I'd open it up to questions.
Questions?
Sir.
Have you thought about or explored the applicability of your technology to home sewage treatment plants?
Yes, and in fact, the origin of this technology and products was in advanced septic systems. And so, that gives us the confidence in the products and technologies because they've been operating as such for nearly 3 years. And so most of our data has been collected at that point. This is now the idea to scale it up, on a larger scale. But yes, good connection there. Other questions?
I'm not sure if I understood the aeration portion of your technology, so maybe my question's not relevant, but does it involve material dispersion, and what type of environmental and runoff testing or modeling have you done?
Okay. Once we start getting too technical, sometimes I have to bow out. So you said a bunch of stuff there, yeah. But what I can tell you is that it's very necessary for the bacteria to have oxygen, right? And so once you start putting this media in the water, the biomass is going to increase. I told you about the lagoon that went from 2,500 up to now 42,000, right? So you're going to need, in many cases, more oxygen to support that additional biomass. Sometimes we have a project where their oxygen is sufficient, and so it's just a matter of introducing the media to the water. But through our computer simulation model, if we determine that, hey, they're going to need more oxygen to support this increase in biological activity, then that's when the microbubble aeration comes in. And as far as the microbubble aeration, that's also used in the advanced septic tank that we identified. And it runs on just a pump, so it's very energy efficient. Okay, it pulls in ambient air and then spits out what we call microbubbles, which are 30 to 50 microns. So just imagine if you're in a pool and you blow a bubble, right, underwater, it'll just float right to the surface, right? So that oxygen maybe stays in the water 5, 6 seconds, depending on how deep you are. The bubbles come in and they just hover in the water for up to 4 hours, which gives it the ability to really, provide that oxygen for the bacteria. Did that answer the question? Or?
Kind of. I think I was curious, does the aeration involve the dispersal of your material? And is the material staying in the water? Is there any runoff possibility? But if there is material in the water, is it biodegradable in the future?
Right, so as far as the media is concerned, it does not biodegrade, it does not break down. We give it a 10-year warranty, but really from our perspective, it should last forever. There's no reason to take it out of the water, to clean it. There's no maintenance. You set it and forget it, and it'll just continue to work for you. The biomass will continue to grow and decay. It's a natural kind of process, giving you that bacteria that's needed to do the job in the water. Hopefully that helps. Okay, any other questions? All right, thank you very much.
All right, so that's Water Warriors. And to round it out, we've got Jonathan Levine with Folia Water, and they are they live in Cincinnati now, via Oakland, California, via New York, Pittsburgh, and they've settled here in Cincinnati for a little bit, so.
Where's the slide clicker? Is there a slide clicker? No? Okay.
What's that?
I didn't quite follow the last one as much.
Yes.
Good afternoon. My name is Dr. Jonathan Levine. I'm the CEO of Folia Water, where we have the world's first water filter that costs pennies and not dollars. So groundwater is a problem of the destitute. This is the NGO, humanitarian, and government space. But safe water is a much larger problem. It's a problem of the low income. 2.1 billion people in the world drink unsafe, contaminated drinking water. This isn't the destitute in rural, frankly, Peru or rural Africa. This is the urban poor who live in the megacities of the world, Manila, Mexico City, Jakarta, right? These are working poor who have incomes, who probably live in a slum, but they go and they buy products at stores. So this is a commercial market. There are 3 billion people in this market. It's called the base of the pyramid. It's the major new trend in the last 20 years is to look into developing countries and say, this is a huge market, 3 billion people making $2 to $10 a day. They collectively spend $20 billion on drinking water, on household purification, and they pay more than we would for this water. Introducing the world's first water filter that costs pennies and not dollars. The reason we're in Cincinnati is that we've got the world's first CPG water filter. Each of our filters is packaged like a simple coffee funnel, just that simple. Kills 99.9% of the bugs, and is a penny per liter. 50 cents for 50 liters, which is about 1 week of safe drinking water. The way we do this is that our papers contain nanosilver, which kills the bacteria and the viruses, and the physical pores of the paper screen out larger germs like protozoa. So it's simple, affordable, again, 50 cents for 50 liters, sustainable, and requires no power. So it meets all the needs of the consumer. And it's a 75% savings compared to the existing major incumbent, which is bottled water, which is growing from a $58 billion market in emerging markets, just in developing countries, to a $203 billion market. And that's the wealthier, but you see that huge push towards safe drinking water being a massive expanding market globally. How are we able to do this? We're a founding team of scientists. Part of my PhD research at Columbia University was that my boss's boss was the head of the UN Millennium Development Project. So we were looking at how to do water affordably but sustainably into developing countries. Modern business theory says that's social enterprise, which is what we are. My co-founder has an undergraduate in fiber science from Cornell and her PhD at McGill in paper chemistry. They asked her, can you invent a kind of paper that would provide safe, germ-free drinking water? She did, and so that's why we now have a company. I asked her something even simpler. I asked her if she would marry me. We're a husband-wife team of scientists, and this is our story. In 2015, Terry's invention went viral. #1 most read on BBC, Time Magazine's invention of the year. We thought, we better form a company. So in 2016, we formed Folio Water, filed the patents. The challenge is, how do we do safe drinking water as a commercial opportunity in this massive base of the pyramid market? So we utilize paper mills for our manufacturing as the world's largest, lowest cost nanofactories. What does that mean? It means we take commodity silver and commodity metal, and for a penny per filter worth of silver, we use standard paper machinery with no modification to make a consumer product. And so my product costs the price of paper to make. And that lets me have a margin. We've scaled up the manufacturing over the last 2 years. We can make 1,500 tons of paper per year, which is 15 million people worth of safe water. In other words, we've scaled the product. We've also tested the product in Bangladesh. If my husband does not buy this, I will write poetry to raise money so I can buy this myself. Similar responses in South Africa and Honduras. So customers love our product. Now the issue is going commercial. Our unit financials are that, again, we make for the price of paper. We've got 1 penny of silver. Packaging is about the same. And we charge 1 penny per liter to consumers, providing a 60% margin to master importer distributors. In other words, standard consumer packaged good retail unit economics with a nice healthy margin for us. This is what a kiosk looks like. This is where the informal sector buys. Mom and pop kiosks, these are called tienditas in Mexico, warangs in Indonesia, and sari-sari shops in the Philippines. There's 800,000 of these stores in Mexico and similar numbers elsewhere. And the key is this is the existing CPG retail chain. This is how P&G makes its money. You're probably looking at 10 P&G products in this photo, realistically. So what does our revenue look like? Per family, $10 per year, $1,000 a year per shop, 100 families. You go through retail distributors who are now reaching, say, 100 shops each, and this is ultimately a master distributor. That's how you cover an entire country. That's actually how P&G covers an entire country, but this is an existing network. This is existing retail distribution. This scales. This is a scalable way to reach into the base of the pyramid, just like Coke. So how do we get there? What's the operational plan? Phase 1, consumer testing. We have partners lined up into Bangladesh, Indonesia, and Mexico, all of whom have expertise specifically in this consumer demographic, in getting consumer information, and have a proven record of working with the Unilevers of the world doing this. Phase 2, later this year, we shift to market pilot trials. Right in the first phase, we're identifying our consumer. In the second phase, we're testing in 10 stores, ultimately expanding in 50 stores through people like Tinoli, which has 21st century data analytics and tablets in mom and pop kiosks. So this is modern 21st century analytics into the informal sector. Do a consumer launch, standard. This is the Wholesale Association of Mexico. This is standard stuff. The ultimate goal is to be in stores throughout developing countries. And if that's the case, because we have this massive market, we join the ranks of sanitary pads, diapers. These are all billion-dollar products that you're looking at on this slide. Consumer health products to mass market staples are huge markets. The key is showing the consumer habit change, proving it at small scale, and then ultimately getting acquired by one of these large distributors or similar. There's smaller people in other countries who ultimately take it to scale, going across multiple markets and getting it into their existing channels to get us onto every single store shelf to be part of the grocery store basket next to soap, which is bought every single week, shampoo, bread, and Folia filters, the next billion-dollar household staple. Thank you.
So questions for Folia?
I can see that you're obviously your main market is for countries that don't have safe water. How about travelers like us going to those
You should subset it and say developing countries, because we, of course, have that problem here as well, as the other companies have shown. Travelers are really a small side market, very competitive, and you're not really going to go to a low-cost thing. As an American, you're going to go buy a Sawyer filter, you're going to buy a name brand. REI is a fairly small space and a competitive space. So that's actually a tiny, lousy market to go into, as we learned 2 years ago. I didn't know that 2 years ago, but that's kind of what we found out.
And a second question was, for recycling water, like gray water that had been used for laundry or something like that, is that going to produce drinkable water?
So you do one thing and you do it well. So we have a very simple water filter that kills the bugs. Taking out surfactants is different chemistry. We actually, this is all patented kind of stuff. So we do have the ability to add features in later years and shift to an OEM technology corporation. But first prove out the sales, later phase, start adding on the IP to grab other kinds of contaminants.
Mine was going to be like another contaminant question, and I'm just curious because I know nanosilver is like an antibiotic, but I'm curious, like, do you foresee the possibility of your technology being like a metal capture filter? I'm thinking of the Flint, like lead crisis, for example.
We have the provisional patent on that. If you give us a few $1 million, we can develop it into a finalized product. But the conventional startup wisdom is to do that in sort of year 3, shift to the OEM, and shift to that. Possibly, Kimberly-Clark, we could get acquired by them, and then they have nice laboratories. If we got acquired by a P&G, we can go to work on that tomorrow. It's very much just a startup strategy and timing issue.
Mm-hmm.
But to repeat, we have provisional patents on all those things.
All right, any other questions?
Cool beans, thanks.
All right, so that's Pipeline H2O 2018. These guys will graduate at the end of May from our program, and we will have a demo day on May 24th, so feel free to come out to a demo day on May 24th just to find out more about these guys and get additional information from these guys. But and if you have any questions, we'll be around for the next few minutes. So that will be down in the beer hall. So it'll be here in Union Hall in the beer hall on May 24th. So look forward to seeing you there. Thank you, everybody.